All right, so I'm recording for the other class. So the kids that are missing, and I do this a lot. So if you're absent, I try to post lessons once in a while. So why don't you decide over there, Christina, who has describe an example or a non-example, or just shout it out. What do we have? Let's start with Lindsay, and then we'll go to Aspen. Lindsay, can you give me an example?
An example would be like a diamond, right?
Okay, sure. Like a diamond. So something like this. Okay. How about Aspen Creek? What's another example? Triangle. Sure. Just a triangle. Okay, Lindsay, what about a non-example? A non-example?
Yeah. Well, I guess it's for the liquor, but I don't really know how to explain it.
Can you show me a picture and I'll come back to you?
Yeah, sure.
Aspen Creek, show me a non-example.
Angle.
Say it again.
Angle.
An angle. Right, because why is that?
It's not a shape.
Because it's not a closed shape, right? So, just an angle. What else? What do you got, Lindsay? Hold it up to that camera.
I'm gonna see if this is gonna work.
So that would be an example. Because,
Yeah.
yes, a rectangle. So a rectangle would be an example. Okay. What about a non-example? Hold it up to the camera, Aspen. Yeah, okay, super. So, intersecting lines and then an irregular polygon. So, like a non-example could just be this, but an example could even be something that looks sort of like that. But you know, I'm interested, guys. One thing I was thinking I would see, and I haven't seen, if it's formed by connecting line segments, what's something else completely different for non-examples? Thank you. How about a circle, right? Oops, that's a square. Let's try that again. How about a circle, right? That's a non-example. Thumbs up, thumbs down. We get that? Okay, let me ask you this. Where would this go if I had this picture?
An example. I think it's an example.
You think it's an example? So, what about with each segment intersecting exactly two others? Look at this segment. It intersects 1, 2, 3 places. So because in other words, like there should be like an interior with no crossovers. So this is a non-example. Okay?
That makes sense.
Okay. So I'm going to go to the next thing. We're going to talk about regular polygons. So a regular polygon, I'll give you one that you all know and love. Equilateral triangle, right? But what's a polygon? Are all triangles regular?
No.
So a polygon is regular, right? If so that's what we're looking at definition-wise. It has to be equilateral. All the sides have to be equal. All the angles have to be equal. What about a rectangle? Where does that go?
non-example.
Right, even though the angles are equal, the sides aren't equal. By the way, the symbols, things we're gonna start working on is making sure we show things. So to show 3 congruent sides, I would use those tick marks. Here I would do something like this. Those 2 are equal and those 2 are equal. You must have learned that before, right?
Yeah.
And then to show congruent angles, you might see like the same amount of marks on an angle. That's a common way to do that. Or you might see on a rectangle all right angle symbols. Yeah? What about another, so examples for regular just mean all, or all sides and all angles have to be the same. So these are all regular polygons. Even so sometimes my smartboard's a little distorted, but it actually looks pretty good. Where non-regular polygons, you could have a triangle, right? It doesn't have to be. It's not that a triangle is not a polygon. It's just for it to be regular, all the angles and all the sides have to be equal. And same with that. Thumbs up or thumbs down? Okay. So, am I going too fast?
No.
Okay. So, here's just like some more of the same, but let's go to concave. This is kind of new for people. So concave, a polygon is concave if and only if at least, this is kind of hard to understand at first, at least one diagonal is not interior to the polygon. So I think of it as caving in. So this is a concave polygon. Because I can take a diagonal and show that it's not entirely contained inside the polygon. So do you guys know what a diagonal is? Everybody? Is that a thumbs up? Okay, so it's a segment that does what? What's the diagonal connect? Lindsay, do you know?
The diagonal connect. What do you mean though?
So like if I have a convex polygon here, the diagonals, you know, they're segments that connect vertices, but they don't connect vertices that are next to each other. So they connect 2 non-adjacent, non-consecutive sides. Because if they connect consecutive sides, then they would be, if they connect consecutive vertices, they would be sides.
Okay.
So Aspen, does that make sense to you guys? A diagonal connects 2 vertices that are not consecutive, so they're not next to each other. So if I just kind of maybe, I think that was earlier in your book, but I was gone for that, so we could write that down here. So a diagonal is a segment, so I'm classifying it as a segment that connects 2 non-consecutive sides or vertices polygon. So let's see how smart this smartboard is. How about that? You guys see that? Can you hear me?
No.
Okay, so that's our diagonal definition, okay? So if I'm just trying to get that to stand out. I guess it was, we'll go black. Okay, so that's kind of an important definition to understand concave and convex. So if I go to a different picture, here's some more examples. Can you see how this is concave because that green diagonal is outside? That's concave. These are all polygons, but they're concave. And this is convex. There's no diagonals in a triangle because there's only 3 sides, and that's convex because all the dotted greens are the diagonals. Okay? So I can we're going, I'll pause that and I'll post it on the website. I'll record it to YouTube and you guys can tell me, you know, if you can find it.
Thank you.
Alrighty. Have a good day.
I know. You're gonna be working also.